டைப் பண்ணுறடி நீ ஓரியன்டேஷன் டைப் பண்ணு தெரியும் நீ டைப் பண்ணுறாங்க சைட் டைப் நான் வீடியோ லெஸ்ஸும் சொல்லி தப்பாக இருக்குது வருண்டா ஓப்பன் பண்ணலாம் போமா அப்படியே ஓடி ஓடி போன பின்னாடி வைக்கணும் அவ்வளோதான்டா லைவ் ஓடிட்டு இருக்கா அப்போதான் வேறு ஃபோனை செக் பண்ணி பாருங்க ஏன் கரெக்டாக தான் இருக்கும் மேலே நிற்கிறவங்க கரெக்டாக இல்லை ஓகே ஃபைன் நான் போய் பார்க்குறேன் இது பார்த்து அந்த பக்கம் ஒரு லெவல்னா 5 lakhs நார்மலாக இருக்கும் ரெண்டெல்லாம் பார்த்தீங்கன்னா ஒரு நாளைக்கு 10,000 நீங்கள் ஆனால் மடிச்சு போட்டு கண்டிப்பாக முடிச்சுக்கலாம் இந்த பக்கம்னா அடா என்சி அங்கே தான் வருவாங்க அவங்க உள்ளே தான் வருவாங்க இன்னும் கொஞ்சம் நோத்தி வச்சுக்கலாம் ரைட்டாக நோத்துறாங்க கொஞ்சம் அவங்க ரொம்ப பீச் கொடுக்கும் வேணா அங்கே நோத்திக்கோ அவ்வளோதானே லைவ்ல விட்டு அப்படியே விட்டுறலாம் சார் பிரின்சிபல் ஸ்பீச் தெரியுமாண்ணா அவங்களும் தெரியுமா அவங்க உட்காந்துருவாங்கண்ணா கீழே உட்காந்து சரி இந்த பசங்க இப்போ இது பண்ணுவாங்கல்ல அதை நான் வீடியோ எடுத்துப்பேன் அது வந்து நம்ம என்னன்னா ஓரியன்டேஷன் இப்படி மாற்றிப்போம் ஓரியன்டேஷன் மாற்றி மாற்றி வேண்டும் சரி பார்த்து யாரோ ஒருத்தர் ஓடித்தாரு ஹலோ ஸ்டார்டிங் இருக்காரு சார் கவர் பண்ணியிருந்தா Caldo, check, caldo. Caldo. Caldo, check, caldo. இல்லை அந்த ஃப்ளவர் இது நல்லா தெரியுங்களா பார்க்க இப்படிதான் வரணும் கீழே நல்லா இருக்குல்ல அவங்க நவன் தான் நம்மளுக்கு தெரியும் ரொம்ப பின்னாடி போயிடுச்சுல அதனால நல்லா அது அப்படியே கரெக்டாக இருக்கும் அவங்க உட்காந்துருவாங்க எடுக்கணும் சார் இது இதோட லைட்டாக சின்ன ப்ராப்ளம் இருக்குது தெரியுதுல தனியாக ஒரு லைன் தெரியுது வீடியோவில் தனியாக ப்ராப்ளமாக இருந்துச்சு மேம் அந்த பசங்களை வெளியிருந்து அப்படியே காத்து சார் வெளியே இருந்து காப்சர் பண்ணுறோம் டிஎஸ்எல்ஆருக்கு நான் வந்து உள்ளே வரும்போது மட்டும் ஐக்கில் எடுத்துக்கிறேன்
A very happy morning to everyone gathered here. It's a great honor in welcoming you all on behalf of Loyola Institute of Technology to Viveka. We are the host of today's event. So now we are going to start our first section. Now I like to invite Mr. Pradeep Raj, senior architect with 19 years of experience in the IT industry, specializing in leading large programs for digital transformation platform enabled by experience of working on blockchain platform interoperability. Lead of client projects in various domains using the leading technologies. Strong background in the leading market edge technologies like cloud, mobile platform, etc. Now I'd like to hand over the section to you, sir. Thank you, sir.
எங்க வர இருக்குது நம்மளுக்கு அதெல்லாம் தெரியலப்பா. வீடியோ ப்ளே பண்ணும்போது கேமரா திருப்பி
ஆப்போசிட் சைடு
அவர் ப்ளே பண்ணும்போது நம்ம என்னென்னா இந்த கேமரா மட்டும் வச்சுருக்கோம். இந்த மாதிரி ரெக்கார்டிங் பண்ணி கிடைக்கும். ஸ்டூடெண்ட்ஸ் மட்டும் தான் பார்க்கணும். ஸ்டூடெண்ட்ஸ் மட்டும் லைவ் திருப்பி அவ்வளோதான்.
நீ எடுக்கிற வேறு யாராவது கூட இருக்காங்க? இது ரெக்கார்ட் ஆனது அப்புறம்
இல்லை சார் அப்படியே அப்படியே அப்லோட் ஆகிடும்.
லைவ் தான் சார்.
லைவ் முடிச்சோடனே அதை போய்ட்டு அப்லோட் ஆகிடும் சார்.
எல்லாமே தேவையில்லாததெல்லாம்
சார் லைவ்னால அப்படி தான் சார் இருக்கும். லைவாக காட்டும்.
தெரியும்.
இல்லை அது எதாவது நான் கொண்டு போகிறேன் சார்.
இல்லை யூஸ்வலாக நான் என்னோட இது பண்ணுறதுக்கான நான் ரெக்கார்டிங் பண்ணிட்டு பேக்ரவுண்ட் மியூசிக் எல்லாம் நானே ஆட் பண்ணி
ஸோ அதுக்காக நம்ம எடிட் பண்ணலாம்ல. இந்த லைவ் போட்டதுக்கு அப்லோட் ஆகாமல் நம்ம எடிட் பண்ணலாம்ல.
டவுன்லோட் பண்ணி மறுபடியும் ரீநேம்
ரீநேம் கொடுத்துட்டு மேபி அப்படி பண்ணோம் இருக்கலாம்.
ஏன்னா சார் தனியாக அப்லோட் பண்ணலாம் சார் வீடியோ டான்ஸ்.
என்ன பண்ணுவேன்
சார் அப்படி பண்ணுறதெல்லாம் தனியாக எடுத்துக்கலாம்.
அது எடுத்துக்கலாம். இல்லை இப்போ 20 மினிட்ஸ் யார் உனக்கான ஃபஸ்ட்டு பார்க்க மாட்டாங்க. அதிலே
போதும் தான் சார் நினைக்கிறேன். கொஞ்சம் இன்ட்ரெஸ்டிங்காக டான்ஸ் பாட்டு இருந்துச்சா இன்ட்ரெஸ்டிங்காக பார்க்கலாம். 2 பேர் தான் சார்.
லைவ் போடுறதே
சார் ஃபஸ்ட்டு 4 பேர் இருக்காங்க. இப்போ 2 பேர்
லைவ் விட்றா 11 நிமிஷம் வேஸ்ட்டாக யாருக்கான நீ நார்மலாக ஒரு வீடியோ பார்க்குறோம் மொபைல் எவ்வளோ நேரம் பார்ப்பேன்? 3 செகண்டே பார்க்க மாட்டேன்.
லைவ் போட்டேன்.
இப்போ லைவ் ஓட சொல்லிட்டாங்க. நான் ஓட்டிட்டு இருக்கேன். கட் பண்ணிடுவோமா?
எனக்கு தெரியல இப்போ கேட்டுக்கிறேன் யாருக்கு வச்சு
வேணாம்
அப்படியே ஓட்டும். ஓட்டும். சரி அப்படி நம்ம கட் பண்ணிட்டு திரும்பி
சரி செல்ஃபி கேமரா நல்லா
12 மினிட்ஸ் லைவ் வேஸ்ட்டாக அப்படியே அந்த ஒரே இது
சும்மா திருப்போமா? நான் பார்த்து
பாஸ் பண்ண
அப்போ ஓகே சார் பாஸ் பண்ண முடியும். அப்போ
அதான் நானும் சொல்லுவேன்.
பாஸ் பண்ணி
சார் லைவ்
டேய் நீ வேறு என்ன பேசுனீங்க கம்பெனி சார்.
Thanks for the opportunity again to discuss something which is very trending in the market and where the industry thinks just going to rule the market in the next 10 years or 20 years or even who knows, right? This is going to rule forever. That's how the internet changed the world, and this could also be a very disruptive technology. So hence people think, there are billions of dollars investment could come on this technology. So what is that? That is called the artificial intelligence. And, so far, the artificial intelligence, wherein the process of evolving, and at this moment, people started using it, and people started realizing the benefits of it. So I'll show you a couple of things. The primary topic today, what we are going to discuss, is the generative AI. So the generative AI is nothing but a part of artificial intelligence technology. So before we discuss what is this generative AI, you would have definitely used the generative AI. So how many of you used this ChatGPT? How many of you used Google Bot, right? So these are all the technologies or the tools created based on the concept of generative AI. So today we are going to discuss about what's next. This is one of the tools from IBM on this generative AI. So before I jump into it, so this artificial intelligence has what is artificial intelligence? How it is evolved? Why this Gen AI people think could rule the world? So that is important to understand. I just want to start with a video. Let us discuss this part. What you have seen here? What you have seen in this video? So this is a very high-speed video, isn't it? So if I need to give the context of this video, so there is a tunnel connecting two different parts of the world where the electricity cable has been laid in the tunnel to transfer the electricity from one country to the other country, right? And this is under the sea. Don't believe me, this is under the sea. The tunnel has been built under the sea, and where you are seeing the being laid over there. So now, if you want to do the maintenance of these kind of equipment, you need to send someone in person, and then they should kind of go and check what is happening there, and what should what are the issues in the channel for the maintenance, and based on that, the maintenance activities should be implemented. You can think of something like implementing artificial intelligence, which could detect the issues in this pipeline. So if you could see on the top left, the visual analytics have been implemented. So this is a part of artificial intelligence. So we have created a model, and this model identifies how many frames are there. For example, you could see that there are two yellow covers on top as well as the down, and the covers have been connected with one of the roller supporting frame. Okay. So at this moment, what has been implemented in this visual analytics implementation? So the model which we have created as part of the artificial intelligence, connects the both covers, and then it tries to identify whether all the bolts are available or not. So at this moment in this video, there are 13 bolts. Okay, should be available. If 13 bolts are available, it has, or we can consider as it is perfect. So when you say less than 13 bolts, we can assume that this is not something correct, or there are some issues in the one. So what the visual analytics could do here is, it can create a ticket, or it can inform the respective company, or it can inform the respective person who is responsible for this. So let them send the maintenance people to look into this issue, and they can kind of come and fix this. So this is one specific visual analytics model which has been built for one of the clients. Okay, let me jump into the other video. You can see this video. See what is happening here. So what will happen here is, so there are trucks. So these are all the cement trucks, isn't it? So when the cement trucks, come from here, so you can see this live camera. So the live camera detects automatically what is the vehicle number, okay? And then it automatically detects whether the vehicle is clean or dirt, okay? So this way, the people who are maintaining this, they should be able to understand, okay, we need to clean this vehicle, or what is the number. So all those things would be informed to the truck maintenance team, and they can take the respective actions. You can see this video. See, you can see on the top right, it says that, okay, somebody is dirty. And you can see this VIN number, it would have been captured 466. Right. So this is another video on the visual analytics, so using the artificial intelligence. So now, if you understand the difference between these two videos, can we take the implementation which had been done for the previous video? Can we apply the same implementation to the second video which I had shown?
Central.
It is not possible. So it is something like, you are writing a program to print the numbers from 1 to 10. Okay? Or at the same time, you are writing a program to print the strings. Okay? Both are two different implementation. So when you try to do the implementation, you would have restricted the first program, to print only 1 to 10, and you will ensure that it is only for integers. At the same time, when I ask you to write a program for string, you will ensure that it is not an integer, but it is purely an alphabet characters, so that you print only the alphabet characters. So by this way, we cannot use the first program to implement the second program. Am I right? Both are two different things. So in the same way, so far the artificial intelligence, or how it evolved, right? So we were creating specific artificial intelligence model for a specific purpose. So you can call that as a prescriptive analytics. You can call that as a predictive analytics. You can call the visual analytics. You can call acoustic analytics. So there are a lot of things. So what is acoustic analytics? So there are manufacturing companies. So in the manufacturing companies, we will implement the acoustic analytics concept. So where it identifies the sound of the machine, and it learns that by self-learning. When the machine sound varies, right, it will be able to identify, okay, something is wrong with the machine. So these are all some of the machine learning models. what we call that as machine learning models, which we create for some specific purpose. Okay? So that is what so far available in the industry. But now what is happening is, that is called your generative AI. Let me show another demo here. Are you able to see this? Okay, fine. See now, I already have set of links here. It says that, show me the delays by source. Okay, just clicking on it here. What I'm getting here. So by the zones, I'm getting the data. Okay, so this is not something new. This is already available in the market and available in the industry. But we should understand the difference. That is important. So what is the difference here is, so far what we have implemented in the industry, maybe from the day that IT has been started. So this is not something new. Whenever you click on this link, you will still get the response. But the response, whatever you are getting, will be very specific. Say for example, if you have a student's table which has 10 columns in that, and when you write a query, only that query will get executed, and based on the query, these kind of charts will be prepared, or this kind of charts the software can give it to you. So that is the difference on the traditional implementation, what we had so far. But the concept which we are going to discuss with the generative AI is, you don't need to write any query prior to deploying it in the systems. Rather, the model can be trained, and when you give a simple English, the model will be able to understand your English. When I say English, you don't need to literally understand that as English. You can understand something like NLP. What is NLP? What is NLP? Natural language processing, right? So why we are calling that as NLP rather than English is, so you can even speak in Tamil, okay? It will be translated into English, and that English would be given as an input to the respective generative AI models, and then the model would frame the query. This is important. The model will frame the query rather than we frame the query and deploy it. We are not doing anything. We are just going to deploy the generative AI model here. The model will do everything or anything, whatever you are asking with respect to the table. So that it will retrieve all the data and then it will give you. So this is.
Are we ready, boys?
In the same way, but what we are seeing here is the implementation, the look and feel, visual is not changing. Still it is same, but the back end, what is happening in behind the scenes, that has changed. So that is what we think, it will transform the industry. So now it has given a set of details here. You can click on it here. So it will tell you. So what are all the details on top of it? You can it shows it. Show me the delayed purchase order in the southeast zone. So what does it mean? Whenever we click on this yellow zone, it means it is a southeast zone. And when I click on it, the model kind of shows here. Okay. So what are all the details? It comes here on the right, you can see. Now, all these are implemented based on the generative AI concept. So I just want to show this demo to you guys before we get into the actual concept. So you can ask a lot of other things with this concept. You can ask to send an email with whatever we have it here. Okay, it will automatically send an email to the given email ID. So previously I have shown this on the website. There is a chatbot, right? In the chatbot, if you tell, okay, send an email to xyz at lid.com, then it will send an email to you. You can ask it to prepare a summary from the data of what it had shown. It will prepare the summary. So all those things are possible. I don't need to tell you because you would have experimented all those things in your, with the ChatGPT experiments or in the Google Board experiments, right? So now let us see what is this generative AI and how it works. So that is important, isn't it? Okay. So what is generative AI? So the name itself defines here that generating something new based on your artificial intelligence is called the generative AI. Okay. What it could generate anything. So you can ask anything to do that with the generative AI. But the thing, maybe you have experimented or you have experienced this, a lot of things. But if you have ever felt that, oh, it is not working as I am expecting, then there is a problem from our side. Why I am saying there is a problem from our side? It is not a human, right? It is a machine. So if you want a machine to do something, what should we do? We should instruct the machine. Okay? So when we instruct the machine, how should we instruct the machine? That is important. So we should instruct the machine with the context, with the purpose, with very specifics. Say like, you cannot just go and ask, okay, write an email, right? It will get confused. What email should you write? You should be very specific, saying that, okay, I'm not going to college today. Please help me to come up with the innovative leave letter. Then it will give you an innovative leave letter. In fact, this is even a generic concept. You can be more specific here, saying that, okay, I'm going for a movie today, but I don't want to inform that I'm going for a movie today. But please let my professor know that I'm not well, so I'm taking off. So if you give it the context, what is the context here? You are not well, so you are asking the generative AI to create something new, so it will generate it for you. So that is how it goes. So whenever you try something with your generative AI tools, the first thing you should keep in mind is you should be very specific. If you are not specific, it will just give based on whatever it learned in the past, right? So it may not work with you. Then you may be very unhappy with that, right? So that is the reason. The first thing which we should remember when we use the GenAI is we should be very specific. So as the text says, like the AI is capable of generating text. So can it generate only the text? No. It can even generate images. So when we say text, you don't need to literally understand that, okay, this is simple text or pure text. The text in any format. So what does it mean? So from the table you have, you can ask the generative AI to summarize the table. So which means what the generative AI will do is, it will tell, okay, so there are 10 columns and that has 10 records. So these are all the details and this is the purpose of each column. So all those things will be summarized. And then you can ask that, okay, can you please send an email? It will send an email. So this is also a part of text. So when we say text, you don't need to literally imagine simple text, right? So sending an email, writing a summary, and then asking the statistics from whatever you have. Say for example, you may have a PDF or you may be creating a thesis or a research paper, and you can input the research paper into the generative AI and you can ask questions. So if we don't have the generative AI, what is the other option we had in the past? We should sit and read. So the paper could be 300 pages and you may be having 10 documents, each with 300 pages. It is very difficult to read 300 pages. So yeah, of course we have come across all those pages. But when you the time, that is important. So when you try to do that, you may take a week or 10 days to complete all the 10 documents which has 300 pages. But when you give all the 10 documents, maybe 300 pages each, when you give it to the generative AI, and when you ask a question, it will answer you what you need. You can ask what is available in the page 10 of this document, it will summarize to you. You can ask what is the value of maybe something has been mentioned in the research paper, it will try to answer you. So what is happening here? When you try to feed in those kind of documents, this generative AI learns it by self-learning. No one is helping it. No one is helping the generative AI to learn. So that is called the self-supervised and self-learning mechanisms by inbuilt by default in the generative AI. So it can give you the results. So you can do a lot of things for that. You can ask it to create a programming, right? You can ask it to create a program, and then what else? You can ask it to fix a bug in your program. What else? You can ask to create a document based on your program. Based on the document, you can ask to create a program. So when I say program, it could be in any language. You can ask it to create in the C language. You can ask it to create in the Rust language. You can ask it to create in the Go. So it is not possible for a human to learn all the languages, right? But the generative AI does for you, which makes your life easier. Right? So that is the power of this generative AI. Of course, we finished the text, and the second one is images. So you can create any images, whatever you ask for. And even if you feed in an image as an input, it can tell you what is the context. Say for example, we can take a photo of this conference hall, and you can feed it into the ChatGPT or the Google Body AI. What it will do, it will kind of summarize what could be the context. It may not be very specific, right? It happens in the LIT or CHENNAI, so this location. Even it can do that. It can do it, but when it will do that, right? The image should have some context. So say for example, when we take this photo, and if that photo has your college name, location, and the audience, the auditorium and the students' details, it can even tell you all those details. But when you try to feed in as a very generic image, it may not be able to tell you that where it is happening and all. So I'm just explaining, or I'm just giving you these reasons. What is the power, or where you could use this generative AI? So that's what I'm trying to explain. Okay, so we discussed about generative AI. What is generative AI? So now I'm going to tell you what is prompt engineering. So if you want to get the best out of this generative AI, you should be an expert with prompts. What is prompt? What is prompt? The prompts are nothing but your inputs, or maybe tuning of your inputs. Say for example, you would have played a lot of games, okay? And when you play games, you know the tricks, right? You know how to win the game in the video games. So you know the tricks, and when you use the tricks, you are getting the best results, and you are able to win the video games. In a similar fashion, if you want to get the best results in the generative AI, you should be expert in the prompts. So prompts are nothing but your inputs, as I've already given you. So what is very important in the generative AI to get the best results? I told you, right? What is important to get the best results in the generative AI? Context. You should give the context. So, how will you key in, or how will you input the context to get the best output using the prompts? So the best prompt is nothing but you are giving the context to the generative AI using the prompts. That is how it works. So you can understand the prompts are nothing but the way that you are giving the inputs to get an output. So the generative AI will not give the output in the way that you want. If you want the output in the way that you want, you should fine-tune the inputs in a way that the model understands. Right? So that is the reason it is called the prompt engineering. So it helps us to create the precise and very precise and innovative and very prescriptive results. Right? So that is the advantage of using this prompt engineering. Now let us get into this difference. So what is this difference between the generative AI and the ML models? I think we have already discussed this. So if you look at this, the traditional AI models, right? As we discussed earlier, we have seen two different videos. So I've already told you that those two videos have been created for some specific purposes. So you could see that in the traditional AI model, the first video, right? So individual siloed models. What does it mean? You can create a model and it will satisfy only that purpose. You cannot use it for a different purpose. So that is the drawback of the traditional AI models. And then we need the specific training, and it needs to be supervised by the humans. Okay? So what does it mean by the specific training? So the video which I had shown on the tunnel, right? We should have feed in the training data as the tunnel videos, so that the model learns the tunnel, and then the model tries to predict the issues in the using the visual analytics. It will identify the discrepancies. Rather, in the other video, if we feed in the tunnel video, will we get the output of the track, whether the track is clean or dirt, the other video we have seen, right? So we cannot exchange the input of those models, or we cannot use a common input to train both the models. You should key in, or you should give the respective or the related data to the model so that it gets trained. These are all the drawbacks or how it works on the traditional AI models. Rather, if you go to this foundation models, I have not used the word foundation model so far. So what is foundation model? Foundation model is nothing but the backbone of your generative AI. So if you want your generative AI to work, it works based on the foundation models. So I have already introduced another word named prompts, right? So whenever you give the prompts, or whenever you give the inputs using prompts, this prompts will reach out to this foundation model, and the foundation model will look into the existing data what you had already provided, if it is an enterprise. If it is not an enterprise and if it is something very generic, it doesn't look for the data. Rather, it will be, giving you the response based on the previous training it had, and then it will give you the response back. Now I have completed the flow of how the generative AI works. If you have not followed me, I'll repeat again for the people who missed it. So you will be giving an input using a prompt. The prompt will reach out to your foundation model. So what is your foundation model? That is your backbone. So this foundation model would have been trained by billions of parameters, not millions, billions of parameters. So there are foundation models available in the industry which was trained using 70 billion parameters. Okay? So when you give the prompts, the prompt reaches your foundation model. And if you ask a very specific question, say for example, you want to understand your LIT student details, then you should have inputted or you should have given access to this foundation model about, for this LIT student details. So then foundation model will access your LIT student database and it will be able to give you the response. But for simple leave letters or for writing a summary email for generic purposes, you don't need to expose your data. Rather, based on the parameters which has been used for its training, it will be able to give the output which you are expecting. Okay? So this is the flow, right? Prompts, from prompts it goes to the foundation models. From the foundation models, the response comes back to the prompts, and the prompts will help you to show the results wherever you want. It could be your edge devices, it could be your UI devices, wherever you want, the results can be taken out. So now, we have discussed in detail about, the use cases, or maybe where and how the generative AI could be used. On a high level, this could be categorized into 4 categories. One is summarization. The second one is conversational knowledge. Third one is content creation. The fourth one is code creation. Okay. So what is summarization? We have discussed a lot of use cases for that. So you can give a document and you can ask a question, or even you can ask a summary. So you can ask a summary, say for example, 300 pages we discussed. You can ask a summary in 10 lines, you can give. You can ask a summary in 20 lines, you will give it in your 20 lines. So that is the power of this generative AI. That is the first use case, is summarization. The conversational knowledge is nothing but, assume that you have a WhatsApp chat between you and your friend, or maybe a group chat. You can feed in this chat as an input to this generative AI. You can give the summary. Say for example, there is a 100 lines of conversation between 3 of your friends, okay? And you have decided to go for a movie. Now you don't have time to just go through this 100 lines to understand what time you need to be there in the PVR theater. You can ask, right? You can just feed in this 100 lines into this generative AI, and you can ask the question, what time should I be there? It will tell you. Just try it out. How many of you tried this? You can try it. So these are all the use cases. These are all the advantages. These are all the features of this generative AI. It will help you. Content creation, we already discussed. So creating a new email is a new content. So anything which is generated automatically by this generative AI is called the content creation. So the content creation could be anything. It could be your email, it could be your data. Say for example, you could have created a software and you want to test it, and you are very lazy to create the data. Yes, you can give the context to this generative AI, and you can ask it to create the data, it will give you. But you need to be very specific. How many records you need? Whether you need 10 test data or you need 100 test data, it will give you. And try all those things when you write a code further in your career. The last one is code. The code is nothing but we have already discussed. You can create programming. When you mention a specific programming language and when you mention the context, it will be able to create the program in a way that you want. Okay? So the biggest advantage in the code creation is when we human, right? When we write a programming language, say for example, assume that you guys know the C language. And when you try to write a 1-2 printing of numbers from 1 to 10 using a C programming language, you will be creating using your own familiar methodologies. Few people will be familiar with for loop. Few people will be familiar with the while loop. Few people will just do the printf for 10 times. So these are all the known methods which human has, and based on that only you will create the program. But when you reach out to this generative AI, it is not that. It knows the concept, so it uses the best applicable methodology or the best applicable libraries available in the programming language, and using that it creates your program, the expected program. So by that way, your programming, the number of lines in your program is very less. Say for example, if you are able to create the program using 10 lines, it could do that in 2 lines. When you use Node.js or TypeScript, it can give you the printing of numbers in 2 lines. Don't believe me? Just try that. Right? So this is the power of the generative AI for the code creation. Now let us get more into what's next. So what is this what's next? Now we have discussed a lot of things about the generative AI. What is the problem of this? We have already told, okay, it has been trained with billions of data. The problem with the training of billions of data, we really don't know whether it is a trusted data or not. Say for example, if I am saying that there are 2 Vande Bharat Express trains from Chennai to Tirunelveli. Will you believe that? It can give you this answer. So now is it running now you should be knowing that, or we know that. So there are not 2 Vande Bharat trains from Chennai to Tirunelveli, not that. It's just only 1 train. Maybe during the Diwali days they had a special train. So for 4 days or 5 days they had 2 trains. Okay. So how will you know that the response which is given by this generative AI is trustworthy, or the data which has been used to train the models are from the trusted sources? We don't have that guarantee. So that is the reason IBM is suggesting WhatsApp. So this WhatsApp is not for open public, but IBM is primarily intending to do this for enterprises. Because in enterprise, we cannot give wrong results, or we cannot give the wrong predictions, which will spoil the companies name. Right. So that is the reason we cannot give wrong predictions in the enterprises. So IBM has come up with the 3 different approaches using watsonx. So one is called watsonx AI. It is specifically for artificial intelligence. The second concept is watsonx.data. It is specifically to connect your data with Watson. The third is the governance, watsonx.governance, where you can monitor and ensure that the data which has been fed into your generative AI or your foundation models, right? The generative AI models are from the authentic sources, because you could control it. You are controlling what resources we are feeding in here for the training purposes, and whether those data is from the authentic sources or not. So that is the reason IBM has come up with the generative AI in 3 different streams. So this AI is nothing but your artificial intelligence. You can use your prompts, you can fine tune it. The second option, say for example, your company have multiple data sources. So one could sit in the Azure cloud, one could sit in the AWS cloud, and one could be in the GCP, maybe your SAP servers or on-prem. So how will you connect all these 4 different sources of systems, right? Yeah, the watsonx.data happens. So it gives you all the permissions. You can reach out, you can just configure it the respective data sources, and it will try to connect it, and then it will retrieve the data based on the permissions you give, and then the model will get trained. The foundation models will be getting trained. The governance aspect is nothing but it is just to know that whether we are using the right data to train it, so we can govern it. Okay, so there is a governance, and there is a control over of the data. So that is the purpose of governance. So as we discussed, why watsonx? I've already told you. So this is open. Okay, people know that what data has been passed to train this foundation model, so you can trust it. So because it is open, you get the trust because you are training the data or you are feeding in the data. So based on that, you are getting the trust. And targeted. Targeted is for a specific target group you can train it. You can use watsonx for your LIT specifically, so that you get the output, the best output for the LIT. If you use the generic foundation models available, you may not get the best results of what you expect for the specific task. That is important. The last one is empowering. What is empowering? See, the other foundation models have been already trained. So to train a foundation model, it is not an easy task. It is not a joke task. So you need plenty of processing power. You need plenty of data you need to collect and you need to feed it. So then think of, say if I say 70 billion parameters have been passed as an input to a foundation model, then think of the data storage capacity requirements you need, the processing CPU requirements which you need to have, the infrastructure requirements which you need to have. So all those things are not a joke. It is a hill climbing task. So that is the reason they are saying instead of using some of the trained models, you can train your model. You can create your own model for your institutions, or you can create your own model for the task which you want to achieve, and you can own it. So by the way, you are not an artificial intelligence user, rather you become a owner of this artificial intelligence model. Because when you create a model, you are a owner of it. When you train the data, you are the owner of that data. So now that you can own it, that is the reason it has been mentioned as empower. So then now we are getting into a bit of technical. So we have already discussed what is prompts, what is foundation models, and how the response comes back, and how we can show it to the people. So those flow and all we have discussed. So to implement this, what is needed? That is called tokens. What is needed? You need tokens. What is token? So I'm keep on telling the word training data. So what is the training data? Right? So whenever you feed the training data into these foundation models takes the input which you have given and then passes the input which you have passed into the system, and it considers or it creates something called tokens. Token is nothing but the input which you have already passed. Say for example, if you just ask how are you, how many words there? How many words we have in the how are you? Just 3 words. But when you pass this as an input into this generative AI foundation model, it could create as much as tokens. How is one token? R is another token. U is another token. If you have a question mark, that is a 4th token. It can restrict with 4 tokens, or what could happen? You can even extend the tokens as you want. So then how you can extend it? You can put all the various combinations here. How R could be 1 token, RU could be another token, how are you could be 1 token. So there are various permutations and combinations could be applied here. But how this will be applied is based on the suggestion or based on the input which you are giving to the foundation model. So how can you give the input to the foundation model? How can you give the input to the foundation model? Using prompts. So prompts is the only way that you can give the input. So you can mention it in the prompts that, okay, so to perform this operation, the minimum token could be 3. So when you say 3, obviously what it will do is it will take only how, R and U. These 3 would be 3 different tokens. Rather, if you say that the minimum token itself is 10, then it will try to have all these permutations and combinations, and it would create the 10 different possible words there. Right? So this is the concept of tokens, and let us see what we have here. So prompt text is converted, we have already discussed, which is our input data. What is the second one? The correlation between words and tokens is complex. I already told you, because it is due to the permutations and combinations which we are trying to apply here. Okay. Then the third one is spaces, new lines, characters, and punctuation marks, or sometimes included in the tokens. So if you increase your minimum token to 20, then all the spaces, punctuation marks, question marks, even that also could be considered as a token. Right? What is the other way? The way the words are broken into tokens from various of language to language. So maybe for Tamil it could be different, for English it could be different, French it could be different. So that's what the token concept is. For a rough idea, we have given that, right? For 10 words, it could be 1 to 20 words. Just an example. Any questions on the tokens? Hope you understand. So here we have given an example, right? How the token is formed. You can see here. So the word, the tomatoes, or this is the input data which we have given, and below we have shown how the token has been formed. Each box is a token. So even in fact, in the tomato, T is a separate token, tomato is a separate token, and E is a separate token. The tomatoes have been split up into 4 different tokens here: T, tomato, E, and S. Rather, here these many tokens have been created because your minimum and the maximum tokens would have been supported to generate so much tokens. Rather, if you restricted something like, generate tokens only for 100 or maybe exactly available for the words in the given paragraph, then it will reduce. So this is how the tokens work. This is called the tokenization. Now, you may be wondering why the tokenization should be here. So if I need to explain why that tokenization we need to consider, I told you, you could give the inputs, you can fine tune the output using your prompts. So when you give a prompt, right, what are you going to give in the prompts? You will be mentioning these parameters. What is my minimum token? What is my maximum token? So there are a lot of other parameters. We can discuss it in the next slide. So along with it, you are going to give one input. So the input could be like, write a summary of leave email, or write or book a ticket in the Book My Show for this movie, right? So anything could be your request. So when you give that request, that plain English would be converted by the foundation models, and then the foundation models would go to these tokens to identify what are the possible strings it should take from here. Okay, so the foundation model will access the tokens and it will take the respective tokens. So based on the respective tokens and based on the task, it will decide should it look for the specific data given by the trainer, or should I answer it generically? That it decides. So based on the decision, if you ask a specific question, say for example, as I mentioned, if you want to know something from the LIT's student related information, then it will go to that student table, and then it will form the query, SQL query, and then based on the SQL query, it goes to the respective table and it takes the data and then it gives us the result table. If it is not very specific, rather very generic, like the email, then it just takes the token from here, and then based on the learning it had, the number of parameters which we had passed during the training, it generates the output. So that is the relation between your prompts, your token, your foundation model, and the result. Okay. So already told you. So there are a few other parameters which you could pass to control the output. So again, these are all the concepts or parameters as part of the prompt engineering. So we have discussed the minimum tokens, maximum tokens. There is something called a temperature. So what is this temperature? Can you temperature is a parameter that controls the randomness of the generated output. So the randomness meaning, so from the tokens and the foundation model based on its learning, you could just put up all the words and it can generate the output. You may not be really happy with it. So that is the reason they are giving you an option to control the randomness. So if you want to control the randomness, what is the parameter you should find in the prompts? If you want to control your randomness of the output, what is the parameter you should control in the prompts? It's temperature, right? So the temperature have the minimum and the maximum value. When you keep the minimum, the output will be different. When you keep the maximum, the output will be different. So that is what it has been mentioned. So you can see that, right? The higher temperature value leads to more randomness, and it focused on the deterministic, it is generated on the diversity. And if you lower your temperature, the value produces is more on the focused and deterministic response. So if you want to get the best result, you need to fine tune this temperature. So what you need to learn from these parameters is, if you are not getting the response from your generative AI tools, you should fine tune these parameters. So you can try to fine tune these parameters and see how the result differs. So that is what we are trying to tell you here. And then there is something called frequency parameter. So this is another important parameter in the prompt engineering. So what is the frequency penalty? So when you adjust the frequency penalty, when you try to generate the generic output, like your leave letter, okay, the words which has been repeated in the letter would be controlled. That is called the frequency penalty. So if you don't control, you can reuse the words as much as possible. But when you try to reduce it, it will try to control the words. That is the frequency. So these are all some of the very high level and key parameters which could be used to control the prompts. But there are a lot of other parameters. Okay, there is a P token and K token, something like that. So you can learn all those things later. So these are all the things which I wanted to tell you as part of the generative AI, what's next, and foundation models. Let me stop here for questions. Any questions? Thank you so much.
ஏய் அபி
Sing hello, sing hello, sing hello, sing hello, sing hello, sing.
ஏய் போயிருவீங்களா எடுக்கிறீங்களா
ஃபேஸ் பண்ணிங்களா
லைட் ஒன்றும் ஆன் பண்ணலையா எப்படி
Hello, check, hello, check, hello.
நீ கவர் பண்ணி
நான் கவரா
இங்கே இருந்தது ஒயர் ஃபுல் வீடியோ ஆஞ்சல கருத்து கருத்து கருப்பு ஏண்டா கரெக்டாக தான் இருக்கு ஏன் கரெக்டாக தான் இருக்கு இப்போ நான் தெரியாமல் இருந்ததுக்கு கீழே இருக்கேன் இப்போ வேறு ஒரு நிமிஷம் அது ஸ்லோவாக தான்டா வருது அது உனக்கு இப்போ புரிய வருது எனக்கு இப்போ லைவ் இப்படி தான் வருது லைவ் திரும்பி கட் பண்ணி திரும்பி விடு லைவில் தான் இருக்கு எவ்வளோ டார்ச்சர் இருக்கு அப்படி தான் தெரியுது லைட் அம்மா கம்மி லைட்டே இல்லை எப்போ விடுதுன்னு தெரியுங்க நான் தான் தெரியும் இப்போ வந்து இப்போ அங்கே உட்காந்துருக்கிறியா இப்போ நான் லைவ் ஆனால் ஓடி இப்போ தெரியும் நபர் இப்போ ஃபஸ்ட்டு கரெக்டாக பக்கம் வச்சு அது என்னன்னா நான் இந்த கொயர் இருக்காங்கல்ல அவங்க வர்றதுனால பிரச்சனை அவங்க மூஞ்சிட்டாங்கன்னா மாற்றிடுங்க இப்போதைக்கு அட்ஜஸ்ட் பண்ண நம்ம உட்காந்து பிரச்சனை கிடையாது பார்த்துக்கலாம் யாரா
I request all of you to kindly rise up as the chief guest is arriving. Please remain silent.
அப்படி வரும்போது எடுக்கும் ஒன்றும் இல்லை அது ஸ்டீவ் கோஸ் நான் தான் எடுக்கணும் ஃபுல்லாக எடுக்கணும்ல ஸ்டீவ் கோஸ் வர நம்ம எடுக்கணும் அட்டன் பண்ணிட்டே தான் இருக்கும் ஆமாம் எல்லாம் லைவில் போட்டோம் பார்த்துக்கேன் திரும்ப விட்டு ஒழுக ப்ரோ ப்ரோ புரியுதா ப்ரோ அந்த ஸ்டெப்பு கானரைஸ் எதியாவது சத்தியம் எதியாவது நீங்கள்
I request all of you to kindly remain silent.
எதுக்கு நமக்கு தேவை திருப்பி விளாடுவோமா ப்ரோ எடு ப்ரோ வீடியோ எடு ப்ரோ முன்னாடி ப்ரோ ஃபுல்லாக கவர் பண்ணோம்
The beautiful thing about learning is that nobody can take it away from you. A very happy morning to everyone gathered here. It's a great honor in welcoming you all on behalf of Loyola Institute of Technology to the IBM's Generative AI Workshop. I'm Kezia and I'm Rebecca and we are the hosts for today's event. Now I would like to invite the choir of Loyola Institute of Technology to lead us with the prayer song, followed by Bible reading and special prayer by our administrator, Reverend Sister Arati Jansidani. I request all of you to kindly remain standing till the prayer gets over.
Let's all close your eyes and invoking the presence of the Lord in our midst. Let us find peace and happiness in our heart by receiving God's blessing. A reading from the book of Sirach, chapter 51, verses 11 to 12. I will praise your name continuously, and I will sing a hymn of thanksgiving. My prayer was heard. For you saved me from the destruction and rescued me in the time of trouble. For this reason, I thank you and praise you, and I bless the name of the Lord. The word of the Lord, thanks be to God. Great things happen when God mixes with us. God, our loving Father, we thank you, we praise you, we adore you and glorify your name, O Lord. This is the day that the Lord has made. Let us be glad and rejoice in it. We are your children coming before you to seek the blessing of God of this day. Father, we give our heartful gratitude that you saved every one of us during the natural calamity, Migjon cyclone. Thank you, Lord, for your providence and mercy. We came to our daily normal life. We also thank the government and officials who render their helpful hand to the every human. Today, Loyola family will joyfully submit at your holy feet Walks on program. Bless the chief guest, Dr. Peter Hofstein, IBM Distinguished Engineer USA, and other resource person. Bless them, bless their family, bless their job and company. Bless and grant them good health and mind and body in order to reach their journey and passion. Lord Jesus, through this event, may our children enhance themselves by equipping new idea pitch and innovative in thinking and doing. For this grace we ask through Christ our Lord. Amen. I ask everyone to join for the Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread. Forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Thank you, choir, for the allied performance, and thank you, sister, for leading us in the prayer. Please be seated. When darkness comes, there is not light of the dark, but light a lamp to illuminate. Now, I would like to request the Honorable Chief Guest, Dr. Peter Hofstein, Mr. Pradip Raj, Dr. Jayakumar Singhal, Mr. A. Prabhakar, and Ms. Sri Kamini to light the lamp.
இது orientation மதி orientation.
On a photo, full. Click.
is not about titles or positions. It's all about one life influencing another. Now I request our beloved principal ma'am, Dr. Sujata Jamana Anand, to welcome the gathering.
Thank you, MCs. So we began with, "This is the day that the Lord has made." Very true statement indeed from the Bible. Because after the calamity we went through, the city went through in the last week, it is a miracle that you and I have been able to be gathered together here, so safe, and attend and go on with our regular life. So thanks to God. Actually speaking, we did not even know whether this day will be possible, because we had a different schedule. We had scheduled this meeting about a week ago with Dr. Peter, and then we had the great deluge coming inside, and we had to reschedule. Then he said Monday, and we were still not ready. And then finally, he has extended his stay, and he joined us today. So on behalf of our beloved founder father, Reverend Father Dr. J.E. Arulraj, our Superior General Sister Lalita, our Managing Trustee Sister Diana Selvam, our Education Secretary Sister Xavier Selvi, our Correspondent Sister Teresa, our Administrator, and all the Sisters of DMI and Fathers of MMI, the two congregations together, on behalf of them, I welcome Dr. Peter to Tamil Nadu, Chennai, and especially Loyola Institute of Technology. This distinguished person with us today. When I was just talking to him, I was like, wow, my God, we have miles to go. He was talking about the birth of the supercomputers, 99, there he is there, working on them in IBM. And he was in Sony, working on the processors for your PlayStation, right? That's so much there's so much part of you. Then he was talking about a hybrid cloud. Then about heterogeneous processors. Then slowly he was talking about genomics. And then FPGA and artificial intelligence for genomics, and how you sequence all your genes. So aren't you impressed? We are all concentrating on one area of study. And here we have Dr. Peter, who's come down all the way from Boston to tell you, guys, don't stick to your domain. Today, engineering is all about being interdisciplinary. If you do not look around you on how to connect your education and the different branches of engineering, we are just not going to be on par in the global arena, isn't it? So, Dr. Peter, thank you for that wonderful message which I got in my limited conversation with you. And once again, on behalf of the students of Loyola Institute of Technology and the faculty, welcome to Loyola Institute of Technology. Can we have a big round of applause? So we have Mr. Prabhakar, CEO at Exhaust, Dr. Jayakumar Singaran, Technical Leader OA, Mr. Pradeep Raj, Senior Architect, IBM, and Ms. Sri Kamini, Technical Program Manager from OA. You're talking about Mr. Pradeep Raj, Senior Architect, IBM. He is not new to our campus at all. Batch after batch, our students have been listening to him and his expertise. And Mr. Pradeep, it's a joy to welcome you. You've always never said no. And our student community is really indebted to the awesome job which you do for us. And we have Mr. Prabhakar. Welcome, Mr. Prabhakar. And then Ms. Sri Kamini. I think she's not new to you. If Loyola has grown every year in terms of training, in terms of introducing new technology and things, it is because of object automation. So I take great pleasure in welcoming Ms. Sri Kamini and Dr. Jayakumar Singaran to Loyola Institute of Technology. It's your campus and you're welcome anytime and any day here. So, how did it all start? We started in the year 2015 when Mr. Ganeshan from IBM, he started introducing us to Watson, which is now Watson X, and life goes on with the changing and the evolution in technology. So we started learning that early artificial intelligence. Slowly, students of Loyola were doing projects on IoT also, combining different areas. And last year, very happy to say that because of IBM, we had the first AI lab established in our campus, sponsored by IBM. So we also use this platform to thank IBM for all what they've done for Loyola Institute of Technology. My dear students, you have a galaxy of technical stars today on the stage. And I don't want to take your time, just interact with them, learn as much as you can, and wait for the day where you will be stars like this, enlightening other people. So welcome all our dear students and all the teachers who put this day together possible. Welcome, thank you.
Thank you, ma'am. Now I would like to request our administrator to honor our chief guest, Dr. Peter, with a shawl, followed by principal with a memento. I request our administrator to honor our guest, Mr. Pradeep Raj, with a shawl, followed by principal with a memento. I request our administrator to honor our guest, Dr. Jayakumar Sangara, with a shawl, followed by principal with a memento. I request our administrator to honor our guest, Ms. Kamini, with a shawl, followed by principal with a memento. Thank you all. I request the volunteers to help the guests to be seated off the dais.
चार किलो ये चार मान
Dr. Peter Crossley is best known for his contribution to heterogeneous computing as a chief architect of the cybernetic process elements in the self-broadband engine process used in the Sony PlayStation and the first supercomputer to reach sustained petaflop operation. After returning to IBM research in 2011, he has focused on optimizing the system roadmap for big data, analytics, and cloud, including the use of accelerated compute. His Early research work on coherently attached reconfigurable acceleration on Power 7, the way for the new coherent attached procession interface on Power 8. Hofstee is an IBM master inventor with more than 100 issued patents. I start with gratitude to welcome our Honorable Chief Guest to take over the session.
Okay. Well, first of all, thank you. I can tell you, I've never been welcomed, like this in my entire life. So it is a real pleasure to be here. I think I didn't know exactly because of all the moves, what my audience would be. When I graduated from Caltech, I did teach second year computer science class. I think my talk is going to be a little bit challenging, but I hope it will be interesting to you. And first of all, thank you so much for that wonderful introduction. Of course, whatever I've been able to do is because I've had the good fortune to work with lots of smart people, and I'm sure there are many smart people here in the audience. Even though my day job is at IBM, I'm a part-time professor at Delft University in the Netherlands, and I really enjoy working with the students there. So what I will do is give you an overview, and this is a fairly broad set of things. So usually I give a talk that is very specific about our open power cores and so on. And I think what I will do today is actually I give a somewhat broader talk. And the topics that I'd like to touch on is first a little bit what I usually talk about in these kinds of settings, which is the open power architecture, a little bit of the history, the cores that are available for students to work with in their projects and education, and even, if you wanted to start a startup company, you could use this idea and do something with it. And then I want to talk a little bit about what has been going on in computer architecture, specifically with the Power 9 and Power 10, more recent microprocessors and what we've been doing there. And then I want to talk a little bit about AI. You've probably had many talks about AI, but I thought it might be interesting for you to hear a little bit about IBM's particular perspective on AI. And then the last piece is going to be, really quite technical, but the power architecture and the systems that we build historically have been very strong database machines. So the industry uses our power servers to run Oracle databases, SAP databases, DB2 databases, and that really has been our strong point.
And I'm very excited now to see that there is an intersection between AI and databases. So I'll talk a little bit about that as well, because I think that that is particularly interesting for the kinds of systems that I have built. Okay. So that, starting with the power architecture. So this actually goes back to the early 70s. I think it was 1974 that AT&T, the telephone company, came to IBM, and they wanted to make a digital telephone switch. And they said that they knew about how many instructions they would need in order to route the telephone call, in the right way through the switch. And they also knew that the computers that were there of the day were just not fast enough. So they came to IBM and said, please help us build a faster computer. Now, a telephone switch didn't have to do all possible kinds of compute. It was, more simple instructions. It wouldn't be doing floating point calculations or anything like that. So John Cock, the chief architect of power, and at that time it wasn't yet called power, he devised a relatively simple instruction set. It was called reduced instruction set, and they worked on this telephone switch. Now what happened is a year later, the project got cancelled. Now, there is actually a little bit of a lesson in this, right? When you work on interesting things, you will often find that the first time you try it, it doesn't actually make it all the way into product, right? But that doesn't mean that the work that you started to do, isn't going to have an impact further down the line. And I've kind of experienced that. I've been very lucky in IBM. I think several of the things that I've worked on actually have made it into product and so on. But a number of things that I worked on didn't make it to product, right? And I think you always have to have that curiosity and interest and try to make sure that you're solving good problems. And if you're solving good problems and you're making good progress, eventually, it'll have to improve. So I'll try to touch on that a little bit as we go. So the power architecture, it started in the 70s. Research in IBM thought that it was a very interesting project, even though it didn't become a product for a telephone switch. They kept it going at IBM Research, eventually worked with the development organization in Austin, Texas, which is where I live, and they built the first generation of power servers. They started to work with Motorola and Apple, so most of you are too young, but if you were a little older, then you might have had an Apple product with a power processor in there. So the architecture, split into a piece that was used primarily for PC type things, like the Apple products, and the server products on the left. Then Motorola, later Freescale, and now Xperia use it for embedded applications. So I think a number of you are interested in IoT, networking, automotive, so the architecture is used extensively in that space as well. And then in 2006, they kind of brought it more back together on a uniform footing. And then since 2019, they actually put the power architecture in the Linux Foundation. You may have heard of something called RISC-V. So what this means is that the architecture itself is now completely open. And people can build their own implementations of the architecture, and you don't have to pay anybody to do that. So that, and we did it to make innovation possible. Now along the line, from a simple instruction set with 218 instructions to today 1419 instructions. This is, so it's very nice to say, okay, well, here's an architecture and it's freely available, you can do your own implementations. 1419 instructions is a lot of instructions to build in a microprocessor. So we thought what we should do is make it a little bit easier for people to get started with the architecture. And so we've created a layering, right? So the simplest form of this, which is called the scalar instruction set architecture. And you'll see an FPGA project that implements that. It's even less than the original, so it's only 129 instructions. And and if somebody is interested in computer architecture, I think this subset of the architecture and the implementation that we have available for you to play with is a wonderful way to get started and learn about computer architecture. Then if you add the floating point operations to that, of course you have more instructions. And then if you want to run an operating system, even very small devices these days quite often run an operating system, and often they run Linux. There's a somewhat larger set of instructions that you need, so we also defined that as a layer. And then in these big server systems, the database server systems that I talked about, those are running the Unix variant, and the IBM Unix variant is AIX. So if you want to build your own database server, you would need to build at that level. But we've tried to make it very easy for people to get started. This slide has some of the details about the instruction set architecture. I'm not going to go through them. But what I would point out is that if you look at the top of this, so when you're doing computer architecture, and if you want to work with the community and you want to do innovation, there are two things that kind of conflict each other. On the one hand, an architecture needs to be very carefully managed, because you want to make sure that if somebody else builds something that's called a power architecture processor, that all the programs that have been developed for power architecture processors are going to run on that implementation. Right? That's what an architecture means. So it's a degree of uniformity. On the other hand, it's very important to be able to do experimentation. So we carved out pieces of the architecture and say, okay, well, this space, if you use these particular registers, if you use these particular instructions, you can define them to mean whatever you want. Now, of course, if you do that, you also have to make sure that the compilers and other things, it's your responsibility to make sure that that works. But this way, we have both a very well-defined set of the architecture that everybody has to build, and room for experimentation, doing new things. Maybe somebody would want to build a version of the processor that has an AI subset and add that. And then maybe a little bit later, the community, again, under the Linux Foundation, says, oh, this set of instructions I think is going to be useful to just about everybody. And then, as a community, we make it a part of the architecture and carry it forward for everybody. So that's kind of the message on this side. So the smallest implementation, and this is those 129 instructions that I think I talked about earlier, you can build this with open source tools on a very small FPGA. And so if you don't have an FPGA, you can even simulate the FPGA just on your laptop, or if just about any computer that you would have would be able to have a version of this architecture and play with it. It's open source. It's a little bit hard to here. It's in GitHub. It's actually one of our Linux software people that put it together. And so it's fairly simple, and it's similar to what you would find in other like the Kennedy and Patterson books. If you're familiar with those, they use a processor. Right? It's very similar in complexity to this one. And again, you can build it with open source tools. You can use FPGAs, and I think it's a great starting point to learn about architecture. And it's a very active project, right? So this is not an IBM thing. It's a community project. 26 people very actively contribute to it. And you can see on this timeline, that it's continuing to get better. If people want to do somewhat more advanced things, like maybe build IoT applications, there's a pair of processors called A2I and A2O, I for in order and O for out of order. And the first of these is a processor core that we actually used in one of our supercomputers some years ago. This one was called Blue Gene Q. And the core processor from that supercomputer we've made freely available. That one is a little bit bigger. You can implement it also on FPGA. You actually have to cut it down a little bit. We did that it's out there also for people to use, who want to perhaps do something a little bit more serious. And then there's also an out-of-order variant of that. Here's another example of a project. This was done in IBM research. Actually, this is another example of a project that ultimately didn't become a product, even though I think it's a very, very nice design, and it worked well. So you see this has 16 of these 8 whiteboards, and in this case combined with a bunch of IP for network applications, like a host Ethernet adapter, a regular expression, and other units in there. You see an XML parsing and so on. So you can build very serious SoCs with those kinds of boards. This one I think is maybe interesting. Ultimately, could be interesting for India. So I work on power processors and systems in Austin, but actually the majority of our work is now done in Bangalore. It's done here in India, and it's not just the design of the processor; it's the design of the entire system, all the way up from the silicon to the system hardware, to the firmware, the starter system, to the operating system. The entire stack is being put together here in Austin. And this chip here, which is a second prototype, but probably fairly close to a product version, was done in China. And China, it also works with this open power community, and they worked a bit with IBM. They did get some help from us. But then they're developing their own server processor. And 2 weeks ago, they announced that they had been successful in creating silicon for one of these server products, and it really seems to work. And my guess is within a year or so, we will see if this entity within China is actually able to realize a domestically developed processor server system based on this architecture. And I think when we succeed in that, I imagine that there is going to be even a lot more interest in this architecture. And then I would point out that here in India, in IBM, there is the knowledge base to do this kind of a thing completely in India, because we're going to do it completely in India. So this is something I'm really interested in. And yes, I don't know if those of you that might look at the Linux operating system. Here's a little snippet of something. It's actually a processor version number that they're upstreaming, which is just kind of a signal. Yes, this is actually really coming, and you can also see it. Yes, it's really allowed processing. Okay. Next, what I would like to do is talk a little bit about innovations in recent power processors. And before I do that, I'll talk a little bit about the cell processor. I mean, for many years, just about every talk I gave was mostly about the cell processor. So I'm trying to, finally start talking about some other things. But I think for this audience, it might be interesting. So when I joined IBM in the research lab in Austin, I joined because the manager that was offering the job said, I want to build the world's first 1 gigahertz processor. Now today, 1 gigahertz is not very fast, but back then, the fastest processors were from Digital Equipment Corporation, and DEC Alpha at, I think it was 300 megahertz. So here was this IBMer that said, I want to make a processor that's more than 3 times faster than anybody else has done. And I thought that was a great challenge. We built this processor, we made it run at 1 gigahertz, we had a paper at an international conference, and then we tried to get it into IBM product, and quite frankly, we didn't quite succeed. The people that are building our mainframe servers and power servers, and now I'm a part of the team that builds those, said, yeah, this is very interesting technology, but our customers, kind of expect different things from us. They expect our systems to be very reliable and all these other attributes. And they thought that going with that very aggressive design that we had done was just a bit too much risk, for the IBM products. And to be honest, at that time, I was a little bit upset. I thought, okay, we've done this amazing world of work. We've gone to a processor that's 3 times faster than anybody else has built, and why? Why can't this be a product? But I had patience. I stayed with IBM. I worked with other pieces, and guess what? A little bit later, Sony had heard about this, and Sony and Toshiba came to IBM because they knew that they had to compete with Intel processors in the game world. The things that they had done previously were not enough performance, and they said, please help us build, a very competitive processor for the game space. And I had the amazing luck that, because of this past work, which again, it didn't lead to a product, but it led to this other conversation with Sony. And then we proposed something where we said, okay, we will do a multi-core processor for you. We'll put 4 power cores on the chip, which again today is very run-of-the-mill, but back then nobody had built a multi-core processor. But there was this CEO of Sony Computer Entertainment. He was a Steve Jobs kind of a person, Ken Kutaragi. And he said, yeah, that's nice, but I want to have something that only IBM can do. So he forced us to do innovation. And what we came up with was we realized that processors were going to not get faster anymore the way we used to. Right? So if you look over the first few decades, from the 80s till the 2000s, with every new generation of silicon, you had more transistors and you could run them at higher frequencies. And most of the performance gains came from technology. And architects had to make sure they use that technology wisely, but a lot of it came from there. We knew, because IBM was a very technology-oriented company, we have not only computer science people, we have very good materials people who understand how this technology will develop. And we knew that you couldn't make transistors. Back then the industry consensus, and there's a thing called the International Technology Roadmap for Semiconductors, said that we were going to have 30 gigahertz processors by 2006. And we knew that was probably not the case. So we told someone, okay, you cannot have a 30 gigahertz processor. And they said, well, what else can you do? And that was where we started to work on this thing that has become, a mainstay of my research, which is called heterogeneous computing, where we say, okay, one way to make a computer more efficient is to make it a little bit more specialized. Right? So in this chip for the PlayStation 3, we had a conventional power processor in there, and then 8 processors that were called the synergistic processor elements that we used primarily to be able to do game physics. That was really our goal. And because supercomputers also are dependent, of course, you do physics calculations there. What we did for the PlayStation actually also led to a supercomputer. So we built the first 1 petaflop supercomputer. It is a slight variation of the chip that we built for Sony and Toshiba for the PlayStation. That one was called Roadrunner. And then, if I fast forward a little bit, with Power 9, we also, again, had a number 1 and 2 position on the supercomputer list with a heterogeneous system that combined NVIDIA GPUs with power processors. So here's a picture of those systems. It actually came in 2 variants. So you see the processor here with its memory, that's very conventional, and then the GPUs. Now, you may be used to GPUs on like PCI Express cards, but these are more integrated and mounted directly on the board. And this was a 4 GPU version of that server. We also see there's an open space. We had a 6 GPU version that was used for one of those 2 supercomputers. That one had to be water-cooled, not hot enough, but it had to be water. So what was special about this is that instead of attaching these GPUs to a PCI Express interface, we actually share the memory between the host processor and the GPUs in that system. And this is something that you see quite a bit now across the industry, right? So the heritage there is, when we worked on the PlayStation, we really wanted to have efficient sharing of memory between the power cores and these SPEs. We carried that concept forward. I actually did some work with FPGAs. We defined an interface called CAPI, and that became Open CAPI. And that has gotten adopted by the industry. It's called CXL. Actually, this is another story where we developed a piece of technology that IBM, from a commercial perspective, really hasn't been that successful with. But it's now become an industry standard through the Compute Express technology, which is the follow-on to PCI Express. Right? So again, if in your career you come upon this thing where you think you've done something wonderful and it's not immediately leading to success, don't despair. Stay with it. You never know exactly how your ideas are going to influence the world, but if it's a good idea, it'll make a contribution somehow. So this was with Power 9. And then, there is also, and this is through Open Power, and maybe related to some of the infrastructure that you have. So we have an interface with NVIDIA, but that interface you can only use for NVIDIA. But we wanted to make sure, again, that people could innovate and do things. So we created another way to get to that interface called Open CAPI, and you can use that with reconfigurable logic to define your own accelerators, etc. So we've done some things there as well. If you look at the cost of a computer today, one of the most expensive pieces is actually the memory. And now with AI and other applications, we need more and more and more memory. And the memory is often not used all that efficiently. And especially if you have an accelerator card that has its own memory that is not shared with the host, then in many cases what you need to do is, if you want to work on a problem, you have to copy it from the host to the accelerator works on it, and then gives a result back. And you can see that all that copying just eats up memory. So it's, in a sense, it's an expensive thing to do. And if memory is a large fraction of the cost of your system, then that's extra problematic. Actually, on top of this, if you're working on something like big data, right, and you might have heard of frameworks like Hadoop or Spark or things like that, and there's a runtime underneath that, which is called the Java runtime, which actually constantly reorganizes how the data looks in memory. So now if I want to take, for example, take a big data application and use my FPGA to make it go faster, what you actually have to do is a process called serialization. You have to take that data in memory, take it out of the Java runtime, put it in a format that your accelerator can understand, copy it over, do your acceleration thing and get it back. And by the time you've done all of this, usually the benefit that you get from your accelerator has been gravely diluted. There's not much left. So there is a software format now called Apache Arrow. And if you work with GPUs, you might also have heard of something called Rapid, which is actually based on this format, where there is a clear definition of how the data should look like in memory. And if you have that, then multiple elements, accelerators and other things can get at that data in memory without having to go through this expensive serialization and copying process. So, I know it's probably not all that easy to follow, but what it means is that this kind of memory sharing that we started with the PlayStation 3 is very essential to attacking what is one of the most expensive components of computer design. So the next thing that I was interested in, or I am interested in, which we're working on right now, is to take that same kind of concept of sharing memory between a host processor and an accelerator to a sort of a cloud-size cluster-level computer. So what I want to do is when I have multiple nodes working on the problem, I want to not have to copy the data from one node to another. I want to be able to directly access the data where it is. And based on this hardware that you saw here before, what we've done is we've coupled computers together. And if I do a load instruction, I can actually, and this is what we do is we use the page tables in the operating system. So usually the page table, you come in with a virtual address, right? So you pretend that you have a much larger address space than you actually physically have on your system. And then there's a thing that is called the page table, and that one determines whether with that address, you go to a certain memory bank or somewhere else, right? And what we do is we actually leverage that to come out over a wire where this computer sort of expects that there's more memory over there. And then we go from one of these virtual addresses to a physical address, right, associated with that port. We come out with that address. But then what we did is we used FPGAs to go back to a virtual address that the next server can understand. So a colleague of mine calls this routing through the page table. And what you can do with this is you can build a very large system. You can actually build a system up to 2 terabytes of memory where it's all addressable. And then if you use these Apache arrow tables that I just talked about, you can in the future build computer systems where you're effectively using memory the way we use storage today, and gain dramatically in efficiency. So this slide talks about how you use the page table to go from an address to some kind of a physical board, and then we added this thing to go from a physical address back to a virtual address to introduce this concept. So, how can you structure your systems? You can, cobble them together like this, and with that you can. Now, let's say that I have a cloud provider, and I have a lot of instances of databases in this cloud, and usually people use a terabyte or 2, but sometimes they need 8 terabytes. So, for example, with SAP HANA. People sometimes need very large in-memory databases. Well, okay, if they sometimes need 8 terabytes, I could put 8 terabytes in every server in a data center, but that's very expensive. I could also make different kinds of servers with 1 terabyte, 2 terabytes, 8 terabytes, but now managing my infrastructure becomes very tedious because I have many different things in my data center. Or I can use this kind of technology to put 2 terabytes, say, in every server, but be able to share memory, steal memory from another server through the technology that I just talked about. And if you do this, you can hopefully see that you can dramatically reduce memory costs. You can do this with small servers. You can also do it with big servers. IBM builds servers for databases that go all the way up to 64 terabytes of memory. So this is 64 terabytes of memory, not storage, memory, DRAM memory, 64 terabytes in one system. And if you do this kind of a trick with those kind of systems, you can get to that 2 petabyte scale that I just mentioned. So now this might again be one of those ideas, that'll take a while. It may be more of an academic thing. We have this capability in our Power 10 processor, but we actually still haven't commercialized it because the gap between the capabilities of this technology and practical things that can use it is still too big. But who knows? A few years from now, it may have led to another change. So yes, with Apache Arrow and these kinds of organizations, I think we can really change the way systems are built. And then if you look at the Power 10 processor, so I just talked about, using processors essentially as network routers and using the page table as a routing table. Well, you might say, okay, how good of a router is a Power 10 processor, say? And if you look here, the main interfaces are memory interfaces, and what we call the fabric interface. So this is what we use for connecting multiple systems together. And it's actually a terabyte per second of memory bandwidth and a terabyte per second of fabric bandwidth. So this is as a router, right? If I want to use a processor as a router, it's actually a pretty compelling router. 2 terabytes per second is a pretty good router. So another thing that we did on Power 10 is AI. So you might have heard of processors having vector instructions. So simply, right, where you have multiple data elements and you put them in a vector and you do something like an addition or a multiplication element-wise in a vector, and that's faster than if you have to do it one element at a time. So we raised that concept one level further to do matrix operations, which you also find in some GPUs, but we were the first ones, I think, to integrate it with a conventional processor. So it's, what also is special about ours is we support all the way up from 64-bit floating point data types that you might use for scientific calculations and things like that, all the way down to like 4-bit things. If you're trying to make a really efficient AI network, you try to not use floating points, but you use something that's called quantization. You use smaller and smaller quantities. You can make your network orders of magnitude more efficient. So we have that capability in there as well. And we, I just talked about terabytes per second of bandwidth. It's very important to bring all that bandwidth down to your execution units so that you can really optimally use that. So we've done that as well. So we do a lot of great things in the power processors and systems in IBM, and I've worked on power processors and systems pretty much exclusively during my career at IBM. But we do many other things as well. Here's an example of a piece of AI accelerator technology that we built into one of our mainframe chips. So there's called tvone. So what you see here, this is a, this processor maybe looks somewhat similar to the power processor that I showed, but it has this, in this case, a separate AI accelerator unit, and they're using it. So IBM mainframes basically run the world. If you're doing a financial transaction somewhere, chances are very high that somewhere in the background there's a mainframe keeping track of this. And they're beginning to introduce AI technology to do things like fraud detection and things like that. So that's why we're looking into our mainframe. They're also building a chip with just those accelerators on it, so more specialized to AI. And that one, here's a picture of a PCI Express card. So very, very power efficient. Right? But at the end, we also worry about things like how much energy things cost, because we're in the world we're beginning to spend more and more energy in our data centers. So energy efficient is also important. Okay, now I'd like to talk just a little bit about AI, about Watson. So I'm sure all of you have heard about ChatGPT and things like that. And in this slide tells you that also from a business perspective, this is very important. Right? The number here that impresses me the most is that they think that they'll have a 7% impact on global, on the GDP, of the world. That is a tremendous amount of money in not very many years, right? And there are not many technologies there's no technologies, I think, that have ever had an impact at that scale over such a short time period, right? So it really is like another industrial revolution. So it has great promise. It can be used for all kinds of important things. But when you ask around and you talk to people in business about whether they think they can really use this, there are some important concerns. Right? So one of the concerns is that if your model is trained with data that is just grabbed from all over the internet, you may have violated people's copyright. And if you're a business and you use the model without paying attention to this, you may become liable for lawsuits because somebody says, well, you're using this thing, but it really belongs to me. Another one is, okay, are these models ethical, right? Are they biased? Right? In many cases, a lot of the data that's out on the internet represents bias, and if you don't pay attention to this and you bake it into your model, then your model may be biased. And if you use this model to, for example, do loan approvals and you have the bias baked into your model, again, this is not a good situation for a bank. Right? And another thing is, okay, in many cases, if a model is available on the internet and you provide as a business, you start working with this model, you want to make sure that the company on the other side is not going to steal your data, right? If they use your interactions to make the model smarter, it can eventually lead to them basically stealing your data and stealing your business processes, right? And IBM's customers would not accept, IBM doing that kind of thing. They expect IBM to be a trusted and ethical company, right? So this is why IBM is now training our own models, right? So we're not necessarily, even though we have researchers trying to make the very best and biggest models also, but the big differentiation for IBM as an AI partner is to try to make sure that we train the model only on data that we have actually rights to, that we legally use. We try to make sure that there's no bias in the models that we create. We try to make sure that the model isn't going to use bad language, when you use it. And we are very careful to make sure that customers end up only sharing data with us when they really intend to share data with us, that we never kind of steal their data indirectly through their use of AI technology. So I think this is really a difference between maybe the industry at large and how a company like IBM goes at this problem. At the same time, just when I talked about processors, it's very important to have a platform where people can do their own thing, bring their own value, do innovation and so on. And for this, IBM has partnered with Hugging Face, so that you can, with all the tools that we build, you can pick up your own models, you can pick up models from Hugging Face, from other companies, and work with them, right? But the models that IBM provides and licenses, and actually the model that we've just built, the Granite model, the first one, the license for that is the same as any other IBM software, right? And again, that's really different between IBM and other companies. We have a platform where you can develop your models, what's next on AI, deploy models. It's very important that your data has all of the right attributes, and so you can keep track of things and properly do that. So we've also changed our data lake architecture to marry up properly with that. So it's called What's the Next Data. And then again, and this is very much a business kind of concern, in many cases there are regulations and you have to be able to prove, for example, if your model doesn't have bias, you have to check it regularly, you have to keep logs of the fact that you did in fact check this. So there's this whole governance module that takes care of that aspect of the problem. So again, it's probably a little bit different than what you might hear in your typical AI talk, right? This is not so much about building the biggest and fastest model. This is about taking this kind of technology and use it for business purposes, but worry about about aspects like trust and ethics and bias. Okay, now the last bit that I'd like to talk about, and then I'd like to leave room for some questions. So the last piece I'd like to talk about is, I told you how the power systems that we build are they're most distinguished as being for very large and powerful databases. And for a while, I was looking at this AI technology and I thought, okay, well, it's very interesting. It is, I fully believe this is going to change the world. This is going to change how we do many, many things. But it wasn't quite so clear how we would especially bring value from our power systems with AI. And then some months ago, I learned that something was becoming very, very popular very quickly. So if you have a large AI model, and there was somebody from SAP that gave a talk recently, and I thought he said it wonderfully. He said this AI model is like having a very smart friend, and this friend, can reason very well, can make a very good argument. The friend can program. They can maybe pass a legal exam. They can maybe even pass a medical exam. But the friend has some flaws. That friend doesn't know anything about what happened in the last year, right? Because maybe the model was trained a year ago, was probably not trained yesterday. And if you're trying to use that friend for your particular context, they're not going to know anything about your context either. Right? So if you look at when these large models are getting deployed, you usually have to do one of two things. You either have to do something that's called prompt tuning, where you provide the question along with some context to the model to answer. But this prompt tuning can be very labor intensive. Or what you can do is you can take the data that you have as a business, and let's take the example, if you have a business, your bank, and you do loan approvals. Right? You can take your loan approval data and make it part of the data that the large model is trained on, but then you have to retrain the model, and that can also be very, very expensive. So what people discovered is, what is very helpful is if I have a database that has, for example, my loan approvals, and now I use that database to give context. I get a new loan approval in. I want to find the loan requests that were most like the current request for a loan that I'm asked to approve for. And what people use for this is something called semantic search and vector databases. The easiest way I can describe this is, so you have a very high dimensional space, say 1,000 floating point numbers. So every object is going to be represented by 1,000 floating point numbers. And you do it in such a way that things that are similar, like the word dog and the word wolf, for example, are going to have 1,000 floating point numbers, which you can think of as a vector, right? That sort of point in the same direction, right? And something like teacup, which is not as much related to itself like a dog and a wolf, is going to, it's going to have some other floating point value that is high, not the ones that were associated with wolf and dog. If you do this right, it actually turns out that it has kind of a meaning. Things that we think of as similar actually come out similar when you try to minimize the vector distance, right? A Euclidean distance or a cosine distance or something like that. So this is now being baked into databases. Right? Large database companies are, if you listen to their keynote talks in the last few months or so, you see that they're all over this vector database concept. So the way it now would work is that if I want to do a loan approval and use one of these large language models to do that, I take the loan request, I find the embedding in this vector space, I find the ones that were most similar to it, and then I provide that as context to the large language model. So now I don't have to retrain the large language model anymore, and I don't have to do all this manual work for prompt. So it looks like a very powerful way to combine database-like technology with AI technology. And as somebody who works on systems that are primarily used for large databases, I'm very excited about this. So we will pursue this with our proprietary technology partners, but we also want to go after it with open source examples. So some of my students in Delft, are now beginning to look at this thing. I think it's a very interesting development. So I already covered this. So now the very last thing that I would want to say is I already mentioned in the beginning that IBM is going to do the majority of our work for these systems right here in India, in Bangalore. I know it's not right next door, but it's not too far away. And I noticed when I'm in our lab in India, we do really attract people from all over India. Right? So, IBM is growing. I looked at, across IBM in India, there's like 3,400 job openings. In the infrastructure division, which is where I work, there's more. I think there were 130 postings or something, and I know there's more coming. So part of the reason that I'm going around and giving talks at institutions like this now is that I hope to kind of spread the word about IBM, the kind of things that IBM tries to do, and hopefully by the time that you're ready to look for a job, you will also consider IBM. So with that, I think I'll stop here and I'll gladly take questions on any topic that you like. Thank you. Challenging, right? It's such a big room of people to step up and ask a question. So, if there are no questions, then maybe I will pass it back to doctors. Oh, okay.
We were talking about a lot of openings coming in on processor designing.
Yes.
So the kind of curriculum which we have here
Yes.
is decided by the university. So we would expect inputs from people like you to tell us how exactly we can head on into projects.
Yes.
So will that assistance be given from your side?
Yeah, no, and obviously IBM has a very strong interest in just for our self-interest.
Yeah.
Absolutely, we should try to do that, right? You gave me a list of the departments that you have here. Every one of those departments to me sounds quite relevant, right? Whether it's either for processor design or system design. There's a lot of software work that's happening here in Austin as well, in Bangalore and in India as well. I myself work on the infrastructure side, but like I said, there's 100-something jobs in infrastructure and like 3,400 in IBM overall, right? So AI, software development, all of these things. But yes, absolutely, specifically for the area of hardware development, but also I think in the area of AI, I would be delighted to have a conversation involving me, involving IBM India, to try and say, okay, what from our perspective, what would a good curriculum look like? What would be a good way for students to prepare themselves for these kinds of jobs? Yes, absolutely.
Thank you so much, Dr.
Yes.
So you are talking about the consonants, right? So IBM plan to take them for enterprise level. But students can take them.
Oh, okay. Yeah, what's a big thing? Good question. Thank you for the question. I actually have a little bit of an answer. Yeah, it's a little bit hard to see, maybe at the bottom. but if you go to cloud.ibm.com, right, and this may come up in some other talk later in the day. You know, there are actually options there to get started with free accounts and begin to experiment with this kind of stuff. There's a lot of good education material also available there. Doesn't take away from your question. I think we need more than just this, right? We need to actually say, okay, this is what a good curriculum looks like. Yes, there are pretty easy ways to get started. Thank you for the question.
Hello. Is GPT generative AI?
I'm sorry, I couldn't quite catch the question. Is GPT-2?
Is ChatGPT?
Yes.
Sir, is ChatGPT a generative AI model?
Yeah, so ChatGPT is and thank you for stepping up, right? I applaud you for asking the question. So yes, you know, ChatGPT is a generative AI model. You can have access to models like that through that Hugging interface, Hugging Face interface within the Watson X toolset. But like I explained, that the model that IBM trained, and the first one that we call Granite, right, is of a similar style as ChatGPT. It's actually, it's a slightly different class, but it's very similar in its purpose. But IBM trains our model differently, right? We train it with data that we think we can really use. We try to make sure that we can control what bad things the model would do, etc. Right? So yes, it's the same class.
What are the most popular generative AI models?
Yeah, so I think the question is what are the most popular generative AI models? I think there are probably people here in the audience that know better than I do. Students tend to be at the leading edge, of picking this stuff up. So the development is incredibly fast, right? So today's best model is not tomorrow's best model. And actually there are two trends there that I find interesting, right? One of them is a trend where these models are getting bigger and bigger and bigger at a very fast rate. But it's also becoming very expensive to train them and even to run them, right? So that's not really sustainable, right? If every time you ask a question to a model, you want to spend more than $1 on compute resources, and you have millions and millions of people asking these questions. That doesn't quite work, right? So along with finding better models, there's an equally important trend to finding more efficient models, right, for things that are at the same level of capability. So when I showed the IBM hardware, IBM was actually at the leading edge of trying to do things not just with very large floating point numbers, but with, all the way down to 4-bit or even some research were 2-bit or even 1-bit quantities to try to improve the efficiency and try to improve the cost, of those models that might have similar capabilities. So yeah, there's kind of, again, I don't think I'm the best person to say what today's best model is, and besides, a month from now it's going to be a different one. But I would say from an IBM perspective, we're very interested in both the efficiency of models, and those aspects that I talked about before that makes them useful to enterprise.
I'm from Electronics and Communication Department. There is what you meant for CLC and IT, but how can we explore more about AI? Sir?
Yes, and we had a similar question in our earlier discussions, right? So it's a little bit difficult for me to give you an answer directly without kind of knowing more about the context, right? But generally, what I would say is there are many people working on AI, right? So what is important, and I found this important in my work with students, is I try to find, for example, an intersection that is somewhat specific and interesting, right? And maybe the intersection here is an interest in educating the world. Then you ask yourself the question, okay, how can we better educate the world? How can we do that? Leveraging AI technology. So that would be an example of taking this very broad space, narrowing it down to a mission that might resonate with you and maybe with the place where you're at, and then say, well, what can I, in that context, what kind of projects can I develop? Right? That might make things a little bit better. Right? But again, this is just an example. But I do think the advice of trying to not just look at AI and do what everybody else is doing, but trying to find a combination of things. Like in my case, when I was talking about this power service that I've been working on all the time, I get really excited when I see an intersection between databases and AI, because I say, oh, okay, this is a place where I can actually make a difference. Right? And one thing that I see here is a lot of passion, right, for bringing education and improving the lives of people across the world. So you can start to ask yourself, what can I do with AI in that context? And if you start to get more precise about that, you're probably not following everybody else. You're beginning to kind of make your own path. So thank you for the question, very good question. And also I saw you help, from this, so thank you for that as well.
Thank you for the answer, sir. Sir, I'm Revati I'm from the Department of CSE, and I have more options regarding AI. Which is the best one for me, Papa? Which is the best path for me to take over my career in the future, sir?
Right. So I think quite a bit of what I talked about over here was sort of pretty hardware focused. But when I talked about how I think systems are going to change in the future with how we look at memory and...
But there are also some negative comments about AI, sir, in the news.
Yeah, no, a lot of them, right? And I hope I explained a little bit, right, about what IBM is doing with AI, tries to, where we try to be responsible, right, and make AI useful for businesses. I know that there are also other things to worry about. Like, well, I mean, very clearly, and in the case of AI, we work, sorry, in the case of IBM, we work a lot with customer support kind of situations, right? So, and a lot of that has been done with call centers, right? And a lot of those call centers are actually here in India, right? And this is a kind of a career that might be very much under threat, right, of this kind of technology, because I certainly am experiencing myself that chatbots that used to be just annoying, right, are beginning to become useful, and that takes work away from certain people. But at the same time, that just like before the industrial revolution, everybody was a farmer basically, right? When work changes, you have to find the other places. And I would say, yeah, focus on those places where AI can do good. Right? Yes, all of us need to be worried about what could go wrong with AI. And IBM, for example, has been working with government in the US and elsewhere on good rules around AI, and so that there is actually legislation about what you can and cannot do with AI. And IBM is absolutely one of the companies that supports in those areas. We don't think it's good for the world, if everybody just does whatever. So there are those concerns, but I really do believe that AI can be used to make people's lives and there are many things you can do with a computer science background. Yeah, so the question was, what is the role of AI in business and how can it help business? I think you saw a number on one of my slides. So 80% of businesses that we talk to think that AI can help them, or have even not only think that it can help them, but have already started projects within the business to make it run better. And I can give you numerous examples, right? So within IBM, a lot of our human resources type processes, like recently I needed, in order to come to India, I think I needed a letter of employment. In the past, I might have had to get a person from the HR department involved. Well, the chatbot with the HR department was now good enough that I could get my letter of employment, without involving a person. This is a services kind of a thing, that is an example. IBM is using AI in our procurement processes, right? When we have to buy stuff, finding out where we can most, where we can best spend our dollar and get things on hand the time that we need to use AI for that kind of thing. I work on chip design and system design. We do a lot of simulations. We are finding ways to make our simulations better by leveraging AI. The list goes on and on and on. I can point you at some other material from IBM. I didn't have time to go through it, but there's like dozens of examples. Right? So, I really don't think there's any shortage of, and I really do believe that this is going to be quite transformative. A lot of things, when you have to write a letter for some particular thing, you will get a draft out of AI. If it's a business letter, right? Rather than a personal one. I don't encourage people writing personal letters, coming out of an AI model. But if you have to write a business letter, you will probably get a draft out of an AI program and then just review it and say, good. When we have meetings, I spend most of my days in web meetings talking to people across the world. We used to have to manually create summaries of those meetings, maybe for people or just to make sure that we can look back at what was discussed and decided. We can use AI models now to automatically generate meeting summaries, and they're of pretty decent quality. Again, a program itself, you may be familiar with a model that Microsoft uses in GitHub, Copilot, that is making it much easier. It's like auto-completion, when you write code, but also on steroids. It recognizes patterns at a much higher level and say, oh, well, this person probably is trying to create a program like that, and it's an entire template. So there's tons and tons and tons of examples. I think we're going, I'm okay, I can go as long as you want, but I also know that we probably have a schedule.
One last question.
One last question.
According to the article I read today morning, it said about an AI which turned, it is about an AI about ethical advice, but it turned dark, like giving racist and homophobic comments.
Yes.
It is a self-learning AI, but why it is the programmer the type of man or?
Yeah, no, I think this is a very clear example actually of what I talked about before, right? So if there's let's say if IBM has sold an AI program to a business and they're using it, let's say they're using it for loan approval, right? And they have that kind of bad bias, that's just totally unacceptable, right? And that is why we look not only at how powerful a model is, but how trustworthy it is, how much bias it has, and what we can do to remove bias from models and convince ourselves, right? Because, you know, IBM actually, when we provide this, we want to put our name on it, we want to give people the same kind of guarantees that we give for other IBM products. And this is very hard work, right? But it's very important work, I think, for the reasons that you mentioned.
But they said it learned 1.7 million human real-life experience and turned that. It is actually true that we can also change AI or
yeah, no, I think if we, you know, we shouldn't just sit back and look at what comes at us, but through, you know, both government regulation and hard work in companies, and, you know, make sure that AI is of course for good, right? And that doesn't happen automatically. It happens through a lot of hard work, right? But it's very important. Yes. Thank you. Thank you. Thank you so much. Again, I really appreciate it.
Thank you, sir, for sharing your valuable insights with us. And now it's time for lunch break, and I request all of you to be present here by 12:40.